Hi, welcome to another quick lesson in organic chemistry. What I'm going to talk to you today about is representing organic molecules. Now, naming organic molecules is a tricky old business because they can have such a variety of forms. Every time you add a carbon, you're adding 3 extra bonds to a potential molecule, and you can end up with millions and billions of molecules. So there is a point where naming just ordinary names becomes kind of pointless because they end up, if you're going to represent the structure, they end up ridiculously long. And that's even true of any other type of representation. So names are one thing that we can give them. Methane, for example, is the name of natural gas, CH4. We have the molecular formula, which is just taking and counting the number and type of atoms, and sometimes you can get a slightly structural version of the molecular formula. We've seen this before when we looked at ethanoic acid or acetic acid or vinegar as CH3COOH. You see H appears 3 times in that formula. But even so, that's a bit limiting in terms of the structures of organic compounds, because many organic compounds can have exactly the same molecular formula but different structures. And so we have the structural formula, which allows us to draw out the entire molecule in 2 dimensions. We just use straight lines to represent bonds. 1 straight line for a single bond, 2 straight lines for a double bond, and 3 straight lines for a triple bond. And then finally we have a kind of condensed system. It's the shortened structural formula, which allows us to write out the formula in words. It's easier to type, for example, than the structural formula, but again it has some limitations. But you need to know what all of these different types look like, so what I'm going to do now is I'm going to show you what they look like. So let's have a look at the board, and we'll look at methane first. So the name of this molecule, the first one we're going to do is methane, and its molecular formula, is CH4. 1 carbon, 4 hydrogen atoms in the molecule. The structural formula is where we draw out each atom and the bonds, and represent the bonds as they are laid out in the atom. Now remember, this is a 2-dimensional structure. The actual methane molecule is 3-dimensional, but this a chemist will look at this and know exactly what to produce. And we'll talk about 3-dimensional structures in another lesson. The shortened structural formula in this case looks exactly the same as the molecular formula because we only have 1 carbon and it doesn't get very complicated. Right, now let's look at pentane. Pentane is a molecule with 5 carbons. It's similar to methane in that it's completely surrounded by hydrogens. So let's just draw it out. It has 5 carbons, and in this case it has 10 hydrogens, C5H10. We're going to talk about pentane again in another lesson, but let's draw out the structural formula. So we put out our C's and we join them all up. So there's our 5 carbons, and then on each of these carbons, all the free bonds on the carbons, all the carbons have only single bonds, so they're free to bond all around. And in this case, the structural formula looks like this. Okay, we put all the hydrogens in. Again, it's a 3-dimensional structure, and again, we'll look at that in the future. Now, the shortened structural formula this time is what we basically do is we write down what's attached to each carbon, and certainly what's attached to each carbon in the main chain. We'll come to that later. So the first carbon is CH3. So we can write CH3. Second carbon is CH2. So is the third carbon. And so is the fourth carbon. So I can go CH2, CH2, CH2. And the fifth carbon, the last carbon, is also CH3. It has 3 free bonds. So as you can see, I'm not going to do any more because it gets ridiculous, and these structures can get very large and complicated. So organic chemistry is really quite a lot to do with the different structures of molecules, and every time you get a different structure you get different chemical properties, and that's important because you can have 2 molecules that are exactly the same, they appear almost perfectly the same, and yet they have different properties. We know that cis fatty acids and trans fatty acids, you might have heard of these things, they look practically the same, and yet trans fatty acids are known to be dangerous for our health, whereas cis fatty acids seem to be perfectly fine. And that's something we'll come to in the future, but essentially those two things are practically exactly the same. They look almost exactly the same, and yet they're very different in their properties. So structure is important, and structure is what gives organic molecules their properties. But I'm going to leave it there. Let's just have a quick look again at the naming of these things. So we have the name, which is methane or pentane. We have the molecular formula, in which case we just write down the number and type of atom. So CH4C5H10. We have our structural formula, where we draw out all the atoms in the molecule. Sometimes we can abbreviate this too. But we draw out all the atoms and their bonds. And we have our shortened structural formula, which again, for methane is just the same as its original molecular formula. But for pentane, we're writing out what's attached to every single carbon separately. So there you go, another quick lesson in organic chemistry. And hopefully, if you have any questions, drop them in the comments below. See you next lesson.